Another part of technology, and what we're going to talk about this week is 3D printing, one of my favorite subjects.
Yep.
3D printing with concrete. So 3D printing with concrete has been around for a while now. In fact, we covered it, it was 2 years ago, 3 years ago.
Years ago.
When we talked about contour crafting. That was a term for 3D printing with concrete from Baruch Kashnevis, a professor of engineering and director of the Center for Rapid Automated Fabrication Technologies at the University of Southern California. Very interesting guy, very interesting what he's been doing, but he isn't the only one. A lot of 3D concrete printing has been DIY with inventors and entrepreneurs and the like, designing their own concrete 3D printers from off-the-shelf parts and open source software. But the printer is one thing, the material is another. What is the right combination of materials that make up the goo that's going to be extruded? What is the strength of the goo? Yeah. What is the right combination that won't slump too much and yet dry quickly enough that you can build layer on layer? And these are all great questions. And questions that a young college student, Austin Thomas, was able to address during his summer undergraduate research fellowship program at NIST. What a lucky guy.
Oh yeah, no doubt.
I want to be Austin.
I was gonna say, that's not bad.
Not surprisingly, NIST wants to quantify the best composition of this concrete material used for 3D printing, and that is the project that Thomas was working on. And by the way, for you who aren't familiar with this, let me just fill you in a little bit. All the methods I have seen on concrete printing work roughly the same way. You've got the printer is like a big crane or robot with an extruder on it, and it is printing the building's shell and maybe infilling some, but then rebar is added and then maybe the entire shell is filled with concrete. So you end up with something that should have the strength of a traditionally poured concrete wall, like the tilt-ups that we see all over the place, except it's has a lot more versatility in terms of design. So think, if you've seen the little plastic extruding 3D printers, this is like that, except 100 times bigger, and it's concrete. Same idea. All right. So there are several issues with printing concrete that Austin had to tackle. First, it has to be liquid enough to extrude. You have to be able to put this goo down a pipe, come out the other end, and come out nicely. It has to be relatively fast curing, because after you've laid down one layer, you've got to be able to come back and lay down another layer without having to wait too long for that first layer to have dried, right? So it has to be fairly quickly drying. And even though it's going to have stuff like rebar that's going to fill in part of that. And the magic mix has to be repeatable and work reliably with a 3D printer. And so, by the way, like you said this before, I think it would have been amazing to be Austin and be invited to work on this project. I think he's like a third-year college student.
Yeah, that's awesome.
So Austin spent a lot of his 10 weeks at NIST experimenting with different formulations, all sorts of different formulations for the concrete, until he came up with this custard-like mix that seemed to work well. Then he added another, this was pretty interesting, he added another nozzle to the printer in addition to the concrete extruder, and this nozzle would print a mesh of carbon fiber to help reinforce the concrete layer. So you'd have one nozzle would lay down a layer of concrete, you'd come back, you'd lay down a mesh of carbon fiber, another layer of concrete, another layer of carbon fiber, all of this to actually reinforce the concrete itself. He then printed some test blocks using that method and stress testing them using a 3-point bend test. I think you all know what that is. You've got two supports right here. You put your brick across it. Then you got a support that comes down in the middle and kind of bends it and tries to break it, measures the force that it takes to break. And they actually performed really well. And this was all how he spent his summer vacation. It was all within 10 weeks.
Wow.
Now the technology is cool. I really dig the technology. 3D printing with concrete is pretty amazing stuff. But what to me really kind of interested me is, not the technology. I mean, forget about the Lego and Minecraft stuff. It's that as we approach manufacturing day, this is the stuff that needs to be brought up. All the crazy advancements that are going on in industries that most people think of as nothing but dirty fingernail work. I mean, when you think of construction, when you think of building concrete homes, you think construction, right? Dirty job. When you think of a lot of manufacturing jobs, dirty fingernail jobs, and that's the way a lot of people view these things. But they're not. They've gotten so complex and so high tech. And people like Thomas, Austin Thomas, he's in the middle of it. And organizations like NIST and even private companies are giving people like Austin Thomas, this experience to work with technologies firsthand. And I think that's just, I think that's the exciting bit about this is, you have these young kids, they're in college or sometimes even before college, they're in high school, and they're getting this chance to go out and experience what these traditionally dirty industries are really doing right now. And it's really amazing. It's cool stuff.
It's amazing. Yeah.
Oh, by the way, Baruch Koshnevis, who I mentioned at the beginning, his company, I think he has left, I'm not sure if he's still a professor anymore in Southern California. His company, Contour Crafting Corporation, plans to start delivery of its first printers early next year. So these are actually being produced and will be up for sale next year.
That's amazing.
I know.
Cool. I mean, the way that a lot of these are being used is to construct, I think, housing for people.
Right.
And people that, especially in disaster zones, we've seen some disasters where this would be really,
that's one
really
idea
valuable.
is a way to quickly build up homes.
Build up homes for people that have had their homes
Yeah.
destroyed by, like, say, hurricanes or earthquakes or whatever it may be. We've seen that.
They're also looking at them also for parts. So, Koshnevis, his company, for instance, is looking at 3D printing entire homes. And it does more than just squirt concrete. He's got robots that lay in rebar, robots that lay in girders and that sort of stuff. But other companies are looking at 3D printing for printing traditional construction parts like concrete beams, right? So rather than creating concrete beams in the traditional way, is 3D print concrete beams because they claim they can give you the same strength but using less concrete. And there's a lot of advantages, not only cost but environmental advantages. Concrete is really CO2 intensive. So interesting stuff.
Good stuff. Thank you, Dirk.